I created the ultimate low-profile, small form factor 13900K PC right here. And this is because I was actually going to be upgrading my 12900KS that's in my main editing rig to the 13900K that Intel sent me to review. And honestly, I just wanted to see how thin I could get away with, especially with one of the higher end rigs that you can build in the enthusiast class right now, and especially with a lot of the conversation surrounding Intel's 13th gen chips being around the power draw. I really wanted to know, with the 13900K being an improvement over the 12th gen that Intel brought out, what happens if you thermally constrain it? Because I am fully expecting that when you benchmark this, it is going to thermal throttle. But my question, and the thing I want to posit here, is whether or not that's still enough to beat the 12900KS, which is the fastest chip that Intel had in the previous generation. And my 12900KS is on a system with a 360mm liquid cooler, so thermals on that hasn't really been so much of a concern. But if I wanted to slim down and get more cores with the 24-core 32-thread 13900K, what's gonna happen? And one of the things that sparked this conversation was the fact that I had purchased this case a long time ago. This is the SFF Time P-ATX V2. This is a special case because it can take up to a full ATX motherboard, which is in fact what's in here, but also still allow you to get a full slot GPU in here. You do have to make a few compromises, but overall it's actually a pretty intriguing case. The motherboard that we're using happens to be the Z790 Aorus Elite AX from Gigabyte. It has all of the features that I need, and it has all of the RAM support to run the 32 gigs DDR5 6800 CL34 RAM that G.Skill sent over. The Aorus Elite AX has PCI Express 5.0 ports. It allows me to get my M.2 in installed with several options for expandability, and in case I want to expand the RAM later on, unlike a normal mini ITX case, I do have a full ATX in here that would allow me to actually go up to 4 DIMM slots. The PC also has a 2TB Samsung 980 Pro and is being powered by the Lian SP750 SFX power supply. This actually went on sale for like $95, which if you follow UFD deals, you'd be able to find that too, because we bring you the hottest tech deals that are out on the internet every single day. Pick this one up. It powers the 13900K as well as the graphics card of choice, which is the RX 6900 XT. I picked this up because AMD started discounting the price on their last gen graphics cards, and for $680, you get a mighty fine 4K GPU. This thing is going to go toe-to-toe with the 3080 Ti, potentially even the 3090 in some games. It's really good for 4K. It also has all of the acceleration that I would need for video editing, so it creates a whole beefy system that is capable of 4K, and with those 24 cores, hopefully a lot of CPU productivity as well. Now for the cooler, this is probably an area where we could have upgraded. We do have a little bit of extra space in the chassis, but the cooler we went with was the Noctua L9i 17XX. So this is the low profile Noctua cooler that allows you to cool the latest 12th and 13th gen chips from Intel, and it fits with the design scheme very well. You can see that it essentially blends in with the Aorus Elite AX. It's a very good looking cooler, but it really isn't rated for what the 13900K can do. The TDP on the L9i is right around 65 watts, which is well below what we can do with the 13900K. So it's more rated for something like the 12400 or potentially the upcoming 13400, as opposed to the fastest chip that Intel has to offer. But how much of a difference does that make really compared to a 12900KS that is fully water cooled? Well, I did all of the comparisons, keeping as much as I could the same. We had the same RAM, we had the same GPU, the same SSD, but the motherboard was slightly different in the 12900KS system. And again, the cooler is completely different on the 12900KS as well. And during all of my testing, the 12900KS was capable of drawing up to 300 watts in peak scenarios, with it averaging around 200 to 250, whereas the 13900K, because of the thermal constraints, peaked around 115 watts and averaged right around 90 to 100 watts. So a big limitation on the CPU because of the cooler that we've introduced. And before you even ask, yes, there was thermal throttling. This chip during the entirety of my testing was running at 100 degrees Celsius, but it never batted an eye. And we'll talk about the sacrifices that actually came with that in a second. But as far as the airflow in this case, because the entire side panel is ventilated, the airflow is actually really not that big of a concern. The GPU, the 6900 XT, had the same temperatures either in the full ATX case or in this one, telling me that it is not at least airflow restrained on the GPU. Some of that hot GPU air is blowing directly onto the CPU cooler and may have affected it there. But when I get to the benchmarks, you're gonna be surprised with how capable a 13900K is, even when it's thermal throttling. So if we take a look at gaming, given that we have an RX 6900 XT, we tested everything at 4K high, and the 13900K won in every single game we tested besides 2, and even then it was a very small loss. Assassin's Creed Valhalla, the 12900KS won in, as well as Horizon Zero Dawn. But when you take a look at a CPU-bound title like CSGO, the 13900K at thermal throttling at 100 degrees Celsius beat the 12900KS. It won in a high frame rate game like Fortnite. It won in Cyberpunk. It's not by huge margins, but the 13900K, being thermally constrained, does seem to be faster in gaming when it comes down to direct head-to-head comparisons. Now, typically the 13900K was running at 5.5 gigahertz and drawing about 85 watts, which is significantly faster than the 12900KS, which happened to be running at roughly 5.2 gigahertz during a lot of the testing that we did, but drawing significantly more power. So the clock speed improvements that are on the P cores on the 13900K seem to still happen even when you have some thermal constraints, and it can run a bit faster than the 12900KS's all-core boost. But then when it comes down to productivity, I tested it out in Premiere Pro, and a lot of the rendering that happened was accelerated by the integrated GPU that's on each of the chips, and they actually happened to finish this 4K 12.5-minute render of a video we've put out here on UFD Tech in just around 4 minutes and 45 seconds. They were roughly neck and neck, but the big difference comes in with Blender, a direct CPU-bound title. This actually made it so that the 12900KS thermal throttled, even with its 360mm liquid cooler, and the 13900K absolutely won. It was anywhere from 9.5 to 20% faster than the 12900KS, again, while it was thermal throttling. The P cores on the 13900K dropped down to 4.1 gigahertz, and the E cores dropped down to 3.3 gigahertz. On the 12900KS, the thermal throttling was present, and the chip dropped down to 5 gigahertz on the P cores and 3.9 on the E cores. But the package power draw, the 12900KS was drawing 300 plus watts during this Blender test, whereas the 13900K was drawing roughly 120 watts. So the 13900K was running slower clock speeds, but thanks to the fact that it has 100% more E cores, it actually still is faster in CPU tests, even if they're of long duration where both of the chips are actually hitting 100 degrees Celsius. But drawing nearly 1/3 of the power, again, because of those thermal constraints, it still managed to win the test. So I actually built this as an experiment because we had the case lying around, but it does appear that a 13900K, even when it's minimally cooled, is faster than a 12900KS, given some of the best cooling that you can get in an AIO. So actually improving the cooling on the 13900K is going to yield even better results for me. If I put this under the 360mm rad, I should probably see faster speeds, or even getting a beefier cooler in this PATX could allow for some extra performance, again, because we did have a little bit more vertical headroom to work with in this case. But regardless, I think I'm walking away from this being very impressed at what Intel has come out with their 13th gen. I do think that there was a lot made of how much power these extra cores are going to draw, and it turns out that when you put them in an environment where they are actually not capable of drawing that extra power, what you see is that the efficiency improvements that Intel has brought on these next gen chips are actually pretty dang good and still capable of beating their fastest previous gen chip. Not even the 12900K, it was the 12900KS that was actually faster clocked that the 13900K managed to beat in my testing. So I think I'm going to swap out all of these parts and put them in a real tower because I actually want to cool my 13900K. I don't want to run it at 100 degrees Celsius the entire time, and I think I'll put something a bit more size appropriate in here, something like the 13400 when that does come out, should probably be in a case like this. But in case you like these smaller PC tests, get subscribed because we're actually going to be putting an RTX 4090 into an ITX case, and we'll be back with that video sometime soon. I'll see you in the next one, friends. Cheers.